All right, take a look at your opener. It says if AB and CD are diameters of your circle, if these are diameters of your circle, then this point right here must be the center of your circle. Now, what we learned earlier in this chapter is that if this central angle is 48 degrees, angle DB would also be 48 degrees. Earlier this year and in previous years, you had learned that vertical angles were going to be equal to each other. So this top angle here would have to be 48 degrees, which means the arc that it makes will also be 48 degrees. So if you notice, those vertical angles, we're going to be making arcs that were equal in measure to each other. Now, this only works because they share that point at the center of your circle. As soon as I go to move that, right, angles 1 and 2 here, yes, those angles are still going to be equal. But if you look at the arcs they make here, AB and CD, notice they are no longer going to be equal in measure. They will have a different relationship instead. That arc that they make, as we'll get to later on in the period, is actually going to be the arcs that are made there, which we are going to call for a term, we're just going to call them vertical arcs. They are arcs that are made by those vertical angles here. That angle that creates them will be the average of those arcs. So we take 100 plus 60, and we're going to divide it by 2. So we have 80 degrees there. Now, before we get to that point, right, one other quick reminder, we're going to have another type of angle come up. And they treat it separately, and I really, in my opinion, don't think they should. We had your central angle. We had our central angle here that was 30 degrees. We said the measure of a central angle was equal to the measure of the arc that it made. Then we had your inscribed angle. Vertex is on your circle, and it was going to be half as big as the arc that it made. So now our arc was going to be 80 degrees. Our third type will look like this. It will no longer remain inside your circle, which is why they do treat it a little bit differently. However, the relationship is the same. Notice where your vertex is. Vertex is on your circle. If your vertex is on your circle, the measure of your angle is half the measure of your arc. So here my arc would be 160 degrees. Right, so it is no different here. Vertex on the circle, whether it appears like this or like this, the measure of your arc has the same relationship. Measure of the angle is half as big as the arc that it makes. Measure of the angle, half as big as the arc that it makes. If a tangent and a chord intersect at a point that is on your circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So angle 1 is going to be 1/2 of arc AB. However, there is another part to this then. I could look at angle 2 over here. Angle 2 makes my arc ACB. So angle 2 will be half of that arc. So really there are two separate ones you could look at, but they're both the same relationship as we've gone over earlier. Intersection on your circle, half as big as the arc that it makes. So let's take a look. Here we have angle 1. Angle 1 makes arc AB. So angle 1 is equal to 1/2 of arc AB. So angle 1 is 1/2 of 132 degrees. So angle 1 is equal to 66 degrees. Being able to go the other way also. If they give me my angle measurement to be 110 degrees, they want the measure of arc EFD. If my angle is 110, my arc will be 220 degrees. All right, one thing that we want to go over then, as they start to move that angle inside your circle, as we went over in the opener and right after, if that intersection is inside the circle, your angle is the average of the two arcs. The key is make sure you can pick out the arcs that it makes. If I'm looking at my 40-degree angle, my 40-degree angle, it makes arc 1, but since your vertical angles are equal, this angle here would also be 40 degrees, and that makes arc 3. So that 40 degrees is the average of those two arcs. Now, that means those other two arcs, they're going to be made by the 140-degree angle. So that would be the average of arc 2 and 4. So if that intersection, if two chords intersect inside your circle, the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So if you look at angle 1 is going to be arcs DC and AB that you're taking the average of. Angle 2 is arc BC and AD that you're going to take the average of. So intersection inside your circle, in layman's terms, you add your arcs and divide by 2. We are also going to look at some examples that take it outside the circle instead. If you move them outside your circle, maybe you have 2 secants, or you have 2 tangents, or you can have a combination of them. Instead of adding and dividing by 2, we are going to subtract your arcs and divide by 2. So you will take your big arc minus your small arc divided by 2. And that will be the measurement of your angle. So inside the circle, we add and divide by 2. Outside the circle, you subtract and divide by 2. So that's your second theorem here, or your third theorem here today. Angle 1 in this case, you take your big arc, BC, minus the small arc, AC. If a tangent and a secant, 2 tangents or 2 secant, intersect outside your circle, then the measure of each angle formed is 1/2 the difference. So we're now going to subtract them of the measures of the intercepted arcs. So the key is always, where is that intersection? If it is inside your circle, such as here, the angle is equal to the sum, or the average, we should say, of the 2 arcs it creates. That would be 140, and then the vertical arc to it, the 112. So inside the circle, we add our arcs, and we divide by 2. Add them together, we get 252. So x equals 126. Intersection outside your circle, we now subtract your arcs. Big arc minus small arc divided by 2 is how we get our angle. So I got 98 divided by 2. So x is 49 degrees. Now, just a couple quick things to look at, some examples that could come up. First off, if I have two tangents, then I only have two arcs that would be created. If my big arc is 260, remember, in a full circle, if this is 210, remember my arcs must add to 360. So this arc here must be 140 degrees. So intersection outside your circle, it is big arc, not 140, 150. I must take my big arc minus my small arc and divide it by 2. 210 minus 150 gives me 60 degrees. Divided by 2 tells me my angle would be 30 degrees. Now, another thing to bring up here, if they intersect inside the circle, yes, you are going to add your arcs together and divide by 2. So 120 plus 40 is 160 here. Divided by 2 does give me 80 degrees. However, be careful where that 80 degrees goes. The arcs that we're looking at, they are made by these angles here. So it is these angles that are 80 degrees. Okay? And then remember, those linear pairs, a pair of angles that form a straight line, must add to 180. So that makes x 100 degrees. Make sure you are matching up the correct angle to the correct arc. Okay, so take a look at our checkpoint. Intersection on the circle is 1/2 the arc that it intercepts. So 120 is half of 240. In this case, intersection inside the circle, we add our arcs and divide by 2. X plus 144 divided by 2 has to equal the angle that makes those arcs. Please notice that 52 degrees is over here on the right-hand side. That means this angle that we actually want is 180 minus that 52 degrees. So that angle we want is actually 128 degrees. So to solve our equation, we multiply both sides by 2. X plus 144 equals 256. Subtract our 144 over. We get x to equal 112 degrees. All right, here's your homework then. If you have any questions, please make sure you let me know. Other than that, please have a good day.